everyone. Welcome to your introduction to chemical reactions. This is going to be an interactive slideshow, so you should have your own version of the slides that you are editing as you watch this video. There are going to be times that I ask you to pause the video so that you have time to process and write down your ideas before we talk about it together. So you are going to be responsible for writing down everything that is in a yellow box. So you guys will see that as we go. And like I said, if I ask you to pause the video, just pause the video so that you have time to write and process in your slides. The learning goals for this activity that we're doing is that you guys can identify the reactants and products of the chemical reaction and then use the law of conservation of mass to balance the equation for a chemical reaction. But before we get into all that nitty gritty, I just want to know what you guys think right now before we get started in this. What is a chemical reaction? Where does this stuff come from for a chemical reaction? And then after that chemical reaction takes place, where does it go? You can use examples from your everyday life that you think are a chemical reaction to help you start thinking about this. So this is like a quick write. I just want you to write anything and everything that you know right now before we talk about what a chemical reaction is in chemistry. So this is your first opportunity where you're going to pause the video to fill out the slide and then come back together and we'll move on. So pause the video here. All right, welcome back. So thank you guys for taking the time to process what you think about this so far. And so the first thing that we're going to do is we are going to watch what do you think happens as a candle burns. This is a nice, simple chemical reaction that we probably all have experience with in our everyday lives. So I just wanted to make sure I had that. All right, here we go. So as we watch this video, what I'd like you guys to do is in the notes of your slide, or you can add a text box on your slide, is just to write some observations and things that you notice as the candle burns and start to think about what is happening. How is this an example of a chemical reaction? What do you think is going on? And then I want you guys to pay attention to what happens and why does the candle go out? So let's just watch this together. Again, write down your observations. And if you guys need to, this is a great opportunity to pause the video to capture your ideas or go back and rewind if you need to watch this candle burning more than once. So again, just watch candles burning. How is this a chemical reaction? Where is this stuff coming from? Where is it going? And now why? Why is the candle going out? What are your ideas? So again, make sure you guys are pausing the video if you need more time to write and capture your ideas, or rewind the video to rewatch what is happening in the candle burning video. So I'm going to give you guys a second to write down any ideas you guys have about what is happening as the candle burns. All right, welcome back. So the candle burning is an example of a chemical reaction. So in any chemical reaction, we're going to have two things. We're going to have reactants and products. Reactants are the things that exist before the reaction took place. And then the products are the things that exist, that are there, that are produced by the reaction. So this is a prediction slide. I just want you guys to think about, as that candle burns, what are the reactants and what are the products? So make a prediction. So again, pause the video as you guys need to write your ideas down. Okay. So now I also want you guys to explain. So why did the flame go out when the container was put over the flame? So again, you guys are going to explain in your own words why this is happening and why we saw that change from the candle being lit to going out once the container was on top. So as you guys need to write your ideas down, pause the video and come back to me. All right, welcome back. Thank you guys for sharing your ideas with me on this slide. Let's talk about what this actually means. Oops. So In the candle, there are carbon and hydrogen molecules that make that candle up. So those are the reactants in the candle. And then as something burns, it's going to produce carbon dioxide and water. So here's the combustion of methane, which is something similar to our candle. So I just want you guys to think about, from methane, it reacts with oxygen to produce carbon dioxide and water. So where did the atoms come from that make the carbon dioxide and water? So again, pause the video here to write down your ideas. Wonderful. Thank you guys for sharing your ideas on this slide. So let's talk about what this means. So I want you guys to watch this animation of what we just had predicted. So I asked you guys to think about, when methane burns, where did the carbon dioxide and water come from? All right, so let me pause, rewind a little bit. All right, so no, it's always going too fast. I'm sorry about that, guys. So here is our methane molecule. So there's our methane molecule and then our 3 oxygen molecules. And so what I want you to watch is what happens as this chemical reaction takes place. What happens to these circles that represent the atoms that make up the methane molecule and the oxygen molecule? Oops, I'll move my screen for you guys. All right, so we're going to watch that one more time. Again, you are paying attention to what happens to the atoms of the methane molecule and the oxygen molecules that we are starting with to end up producing our carbon dioxide and water molecules. All right, there goes. All right, what are you guys observing? What are we seeing? What's happening to the atoms we start with, and what's happening to them after this chemical reaction? All right, so one of the things that you guys are going to experience a lot in this class is called a chemical equation. Now, you've probably already seen some chemical equations in your other classes, and what you will notice is that there are regular sized numbers in front of some of the molecules, and then there are small numbers after certain atoms within the molecule. So the little number is called a subscript, and this tells us how many of a certain type of atom there is within the molecule itself. So like when you were looking at methane in the last one, there it was CH4. That subscript, the 4 next to the hydrogen, that's a subscript. That is telling us that in a methane molecule, there are 4 atoms of hydrogen. And because carbon didn't have a subscript, that tells us there's only 1 carbon atom in a methane molecule. So that's why it's CH4. Then you guys will see a bigger number, and that's called a coefficient. And it tells us how many of a particular molecule there are. There is a coefficient in front of the molecule and a subscript after the atom, then you're going to multiply them together. And so we're going to talk about this and why it's important as we go through some examples. So this is what it looks like for the methane example that we just saw. So the coefficient here in front of the oxygen tells us, or in front of the water molecule, it tells us how many molecules there are in this chemical reaction. So we have 1 methane molecule. So if you never see a coefficient, that tells you that it's 1. If you do see a coefficient, that tells you how many there are. So we have 2 oxygen molecules and 2 water molecules. And so remember, the subscript tells you how many atoms of each type are in that molecule. So for water, it's H2O because there's 2 hydrogen atoms bonded to 1 oxygen atom to form our water molecule. So I want us to just pay attention to the number of atoms and that we have from our reactants and our products of a chemical reaction. So what I would like you guys to do is you are going to pause the video here, and I would just like you guys to fill this out And then when you're ready, you can come back and we'll go over the answers together. So what you are going to do is you are going to look at how many carbons you have from the reactant side and the product side. So remember, when we write out a chemical equation, the reactants are always on the left side of the arrow, and the products are always on the right side of the arrow. So how many carbons, hydrogens, and oxygens you have from our reactant side and our product side. I will remind you. So, and just as a reminder, when you have a subscript and a coefficient, you're going to multiply them together. So I want you guys to practice this on your own for a second. So you're going to pause the video, and after you write down your answers, we'll go over them together. All right, welcome back. So let's go over these answers together. So we're just going to look at the reactant side and then the product side for each of our atoms. So we have one C here to represent one carbon. Do we have carbon anywhere else in our reactant side? The answer is no. So from our reactant side, we just have one carbon. What about on our product side? I see one here. Do we have any other ones? Hopefully you said no. So we just have one carbon. Then we look and we want to look at hydrogen now, our H's. So remember, because of this subscript right here, this tells us that we have 4 hydrogens. And so the tricky thing to remember is that the subscript only applies to what's next to it. So the 4 does not apply to the amount of carbons. It only applies to the number of hydrogens. So we have 4 hydrogens on our product side. Sorry, there's my dog. And now we need to look at our reactant side. So we have 2 hydrogens, a part of H2O, but we have 2 water molecules. So we need to multiply these 2's together. So 2 times 2 is 4. And you can visually think about that too. If we had oxygen and a hydrogen to form our water molecule, and we know that we have 2 of them, so I'm just going to draw another one. And you counted up how many hydrogen there are, we would count that we have 1, 2, 3, and 4. So that just helps you guys visually see where that 4 comes from. Now we want to look at our oxygen molecule. So we can see here that we have 4 oxygen molecules from our reactant side. And now we need to look at our product side. And we can see that we have 2 here, plus another 2 from our 2 water molecules. So that also gives us, 4 oxygens total. Now, what do you guys notice about the number of each type of atom on our reactants and product side? Well, I hope you guys noticed that the number of atoms from our reactants and product side and the types of atoms stay the same. So what does that mean? Why does it stay the same? So again, I want you guys to look at this. So my question to you is, are atoms created or destroyed in a chemical reaction? So use what we just saw on the previous slide and this diagram here of combustion to support your answer. So pause here, write down your ideas about if atoms are created or destroyed, and using what we saw as evidence to support your answer. All right, welcome back. So hopefully you guys saw that you explained that atoms are not created or destroyed, because however many atoms we had in the beginning, the types and the numbers remain the same after the chemical reaction. This is important as we go through different types of, this is going to be important in chemistry. So I also want you guys to think about, in a physical change, like changing the state from a solid to a liquid, the substance itself does not change, right? If I have a pot of water on the stove and I boil it, it's just turning into water vapor, but it's still just a water molecule. So how is a chemical change different than a physical change? So think back to our candle burning or our combustion of methane because those are examples of chemical changes. How are they different than our physical ones? Pause the video and fill out this slide. All right, welcome back. So let's put this all together. So molecules are made of, molecules made of only carbon and hydrogen are called hydrocarbons. So we see this a lot in our everyday life. And the candle and methane hydrocarbons react with oxygen in a chemical reaction called combustions. Now, later on, we're going to talk about all of the different types of chemical reactions that we have and the rules that they follow. But right now, we're just going to focus on these to help us understand reactants and products and this thing called the law of conservation of mass. So the law of conservation of mass says that whatever we have before a chemical reaction needs to be there after the chemical reaction takes place. We cannot create or destroy atoms. And so what I'd like you guys to do is prove that with this slide. So this is a new hydrocarbon for you guys. This is propane. Like you might burn at your house or when you use a grill, most of the time they use propane. So what I would like you guys to do is to look at the reactants and make the products. And you guys know how to make molecules now. So I'd like you guys to, you can't make any new ball spheres here. Your carbon are represented by red, your hydrogen are represented by white, and your oxygen are the blue spheres. So I'd like you guys to do on your slide is rearrange them into the product to show that we are abiding by the law of conservation of mass. So pause the video, try it out, and then we'll talk about the answer. All right, welcome back. So hopefully you guys got something like this. You didn't have to make any new spheres because we didn't have to make new atoms, and you didn't have to delete any spheres because we didn't destroy any in a chemical reaction. During a chemical reaction, we are just rearranging the atoms that are present into different molecules. So we start with propane and oxygen, and through the chemical reaction of combustion, we are able to produce carbon dioxide and water. But the amount of atoms never changes because we have to follow that law of conservation of mass. So we see that we still have 3 carbons. They just went from the propane and were rearranged into a carbon molecule. And then our oxygen are now a part of carbon dioxide and water. And the hydrogens that were originally a part of propane are now a part of water. But those numbers didn't change. And that is one of the biggest ideas I want you guys to understand, is not only being able to identify the reactants and the products in a chemical reaction, but understanding that the amount of the atoms from the reactants is going to be the same in the products because we have to follow the law of conservation of mass. We cannot create or destroy atoms. So now I want you guys to do a little bit harder of a practice, and we'll come back together and talk about this. So pause the video, fill out this table, and then we'll talk about the answers together. All right, welcome back. So let's talk through the number of carbons on our reactants and product side. So remember, this 4 only applies to the carbon. This 10 applies to the hydrogen. But because there's a coefficient, we have to multiply the 4 and the 2. So 4 times 2 is 8. And we see that carbon dioxide here is the only source of carbon on our product side. And so we take 8 times 1 to also get 8. So far we followed the law of conservation of mass with carbon. The number of carbons on our reactant side is equal to the number of carbons on our product side. But you have to do this for each type of atom. So I'm going to switch up colors. So hydrogen, we see that we have in this hydrocarbon, we have 10 hydrogens, but there's 2 molecules of it. So we have to take 2 times 10 to get 20. And there's no other source of hydrogen from our reactant side. And now we are over here. And so water has 2 hydrogens, but there are 10 water molecules. And so we see that we have 10 times 2 is 20 as well. Now we need to look at oxygen. So I'm going to make this one purple. So O2, our oxygen molecule, each molecule has 2 oxygens, but we have 13 of those oxygen molecules. So 13 times 2 is 26. And now we need to look at how many oxygens we have in our product side to make sure that we are following the law of conservation of mass. So we have 2 sources of oxygen on our product side. It comes from the CO2 and the water. So we need to account for both. So in CO2, each CO2 molecule is going to have 2 oxygens, but we have 8 of them. So we're going to do 2 times 8, which is 16. But then over here, we have oxygen as well. So for every water molecule, it's going to give us 1 oxygen atom, but we have 10 of them. So 10 times 1 is 10. So we add those 2 together to get 26. So double check your work. Were you able to track the atoms from our reactant side to our product side to make sure that we are following the law of conservation of mass? Now, this is going to be important as we move forward because we're going to talk about different types of chemical reactions that take place. And we're going to talk about how do you predict the products of those chemical reactions. And so you guys are going to be asked to make sure that your equations are balanced so that we make sure that we're not creating or destroying atoms in our chemical reactions. All right. All right. So let's move on to our next one. All right. So now what I would like you guys to do, that we've practiced this a little bit together, is I want to give you guys another chance for visual learning. So we're going to use a PhET simulation for you guys to visualize this some more. So there are some pre-activity questions here for you guys to practice that. And then you guys will use the PhET simulation to track chemical reactions and where and what types of atoms in our reactants and products and how many there are to make sure that we're following those laws. So this will be good practice for you guys. And if you are still struggling, as you scroll down to the bottom of your PhET simulation student page, you guys will find an appendix here. And it goes over all of the vocabulary again to give you guys some additional resources. So let me know if you guys have any questions. And hopefully this PhET simulation will help you better too. Have a great day.